Hi, dear students. Today I'm going to continue lesson 1 from IGCSE chemistry, pages between 14 and 15. So the topic is the Earth crust. So most of things that happening like chemical reactions or many things are happening in Earth crust. One important place of the Earth crust is volcanoes. We can receive many things from volcanoes through the volcanoes, like carbon dioxide, which comes from below than the crust, like mantle. Okay, so another one is water vapor and molten rock. The molten rock is the most useful for limestone, to extract the limestone from the earth crust. So this is the option that we can get a limestone from molten rock, which comes from the volcanoes. And the volcanoes is the place that lots of chemical reaction happen, and the place is the way that many chemicals can goes up from the below than the crust or in the crust. And the another inner core or outer core, both of them are part of they construct core in the center of the earth. So it produces radioactive energy to run a rock cycle. We have a cycle, which means that rocks can be moved around the earth. Okay, so all the surface of the earth, uh, we have rock, we have land, either with the land that we are living on it, or our ocean, the bottom of the sea or ocean. So uh, the rock or land can be moved, but the movement is very very slow, and even we cannot feel that. Each movement can be measured during many years, okay, or after many years, that can be measured or can be obvious. So this movement of the rock can be powered by radioactive energy, which is produced by core, either outer core or inner core, both. Okay. Be informed that the size between the distance between center of a core to the earth crust is over 6,000 kilometers. So the thickness or the size of actually land mass is around 50 kilometers. Okay, the place there is a land. Okay, but the bottom of the ocean, the land, the thickness or the actually the size of the land in the bottom of the ocean or sea is around 5 kilometers. Okay, so we can see that the mass of the land is thicker. Okay, the place we are human are living actually. So as I said, the most useful place actually, molten rock is the most useful to get limestone. uh, for use of limestone, You need to self-study on for figure 1.17. Okay, just try to have a memorization for use of limestone. And this compound, this chemical, has another two important related compounds, related chemical. One is quicklime, and the second is slaked lime. Okay, these are other two related compounds of limestone. In laboratory scale, okay, in laboratory, there are many experiments that have been carried out for limestone. If we have a limestone, limestone is actually calcium carbonate. Okay, so calcium is a one type of metal, and carbonate is a non-metal actually. The combination between calcium and carbonate, we can get limestone, or actually it's carbonate calcium. As I said, they are available a lot in molten rock from the volcanoes. So if we have limestone and if we add water, nothing happens. There is no reaction. Okay, and but on the other side, instead of adding water, if we give a heat, if limestone has been heated, so we can get quicklime. The quicklime is from the limestone, is one product from limestone, which there is no CO2. If you check the chemical symbol here, CaO, calcium oxide, there is less C1C and O2, meaning CO2 left the place, the chemical reaction. So this compound on calcium oxide is quicklime, and again, if we add some water, there will be an exothermic reaction. Exothermic reaction, that means the reaction produce heat, produce thermal. Okay, is a exothermic reaction means giving a heat, or release a heat actually. So the product would be slaked lime. Okay, is calcium hydroxide, CaOH2. So if we add another more water, we can get lime water. It's alkaline solution actually. There is more and overloaded water actually in slaked lime, that we can get lime water. Okay, it's a alkaline solution. So here you can see that we can use limestone to further reactions and get quicklime and slaked lime and lime water. This process that can be carried out in laboratory scale, in laboratory environment, actually these are same, are happening in our earth, in our daily life. So we have limestone cycle on the earth. When there is a calcium carbonate or limestone, okay, in a place which the place is hot, there is heat enough by sun. Okay, there is like some the place like desert region or hot places, so carbon dioxide can leave the limestone, as I said in the previous slide. um, the carbon dioxide will release from this compound, then compound change to calcium oxide or quicklime. Okay, this one, then it can receive some water. I don't know, from lake, from a rain. This is happening naturally in environments. So if this compound quicklime receive water from wherever, so it would change to calcium hydroxide called slaked lime. Then if this compound exposed to more water, then it would change to calcium hydroxide, which is in aqueous solution called lime water, but lime water has more water. Okay. Then again, if this chemical, okay, calcium hydroxide or lime water, receive receive what we call carbon dioxide, receive uh, receive calcium carbon dioxide from atmosphere of, or if the place has a factory or polluted with carbon dioxide, the atmosphere is polluted with carbon dioxide. So this compound lime water can be changed again, can return to the calcium carbonate, which is called limestone. Okay, this cycle is happening naturally on the earth. Depends on the condition. The condition is hot, or there is enough water by rain or rivers, or if there is pollution like carbon dioxide by factory or something else. So please leave comment down as your attendance. I will check, and then that's all. Take care and stay safe at home. Thank you so much.